All right, so today we're going to continue building on to kind of what we've already been doing with circuit analysis. So far we've looked at simple circuits, which is just one voltage source, one current carrying wire, and one resistor, something to make use out of all that electricity. Then we looked at a series circuit. This is where all of the resistors are kind of in one loop that the electricity or the electrons flow through. We learned that the current is the same for all resistors, but we know that the voltage drop is different. And over here, we've got a parallel circuit. Essentially, this is where there are multiple paths for the electricity or electrons to go through. So the electrons could go, from here, that loop, or that third big loop there. With parallel circuits, what we saw is that the voltage is the same for all resistors. But then what we're going to see is that the current is different through each resistor, essentially through each path. So where can we go from there? Essentially what we're going to look at now is voltage source. We're going to come up. We're going to have one resistor there. Made that one a little bit long, that's fine. And then we're going to have a parallel circuit. I'll make it a little bit complicated. And we better go ahead and have the electricity go back through there, back to the voltage source there. All right, and then let's even give some values here. We're going to call this resistor 1, and we're going to say that it has a resistance of 1 ohm. We got resistor 2 here. Let's go ahead and give that 2 ohms. Resistor 3. Oh, let's go ahead and let's just keep that trend going. 3 ohms. Resistor 4 here. 4 ohms. Just kind of keep it easy. All right. Voltage source, we're going to say that this has got a 12-volt battery powering the whole thing. All right. So how do I go about analyzing this? A couple things I might want to ask is, what's the equivalent resistance? What's the total current kind of flowing through this thing? What is the current through resistor 1? And then I would also say, what is the change in voltage for resistance 1? And then essentially we could find all this for all 4 resistors. So we're looking at the current and the voltage, or the voltage drop, I should say, through our 4 resistors there. All right, so I'm probably going to need a calculator at some point. So equivalent resistance, and essentially I'm going to come back up here. Some of the things we can do though is we can start to combine certain resistances that we know we can do easily. So for instance, I have these 2 resistors in series here, and I know that the equivalent resistance for a series circuit, let's even add it here, is equal to R1 plus R2 plus R3. Bear with me on that one, plus whatever, okay? So I know that I'm just adding the resistances together. So I might even go down here. I would say that the resistance for resistors 3 and 4, okay, since they're in series, I can just add these 2 together. So 3 plus 4, that's 7 ohms, okay? But they are in parallel with resistor 2. And so in parallel, one thing we do is, so with my parallel circuits right here, the equivalent resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus, you could do that for infinity if you have an infinite number of resistors. Big thing is that you raise it to the -1 exponent there at the end. All right. So I've got the 2 ohm resistor, and I can even rewrite this circuit now. Just kind of show you what I'm doing here. So now we're looking at the sound effects just help make it fun. All right, so I've got 2 ohm resistor there, 7 ohm resistor there, and this guy's still 1 ohm resistor. All right. After I've combined 3 and 4, I get the 7 ohm resistor. But now 2 and 7 are in parallel with each other. So if I want to know what's the equivalent resistance for this part right here, what I'm going to do is I'm going to take, so let's even call that R2 plus 3 plus 4. I just needed to come up with some naming scheme. Really what we're going to have there is we're going to have 1 over 2 plus 1 over 7. That's all raised to the negative 1 exponent. That I can't do in my head, so I better go ahead and open up a calculator quick. So parentheses, let me actually show the work I'm doing there. All right, 1 divided by 2 plus 1 divided by 7, close parentheses, x to the y, negative 1 equals 1.56, I think sounds good. All right, so I've got equals 1.56 ohms. All right, so now I can even rewrite this part where I've combined these two. So now I've got voltage source, resistor 1, resistor 2 through 4. This one's still a 1 ohm resistor, and now this one is a 1.55 ohm resistor. These two are in series, so I could rewrite these just by adding these two resistors together, just like we did here. And really what that's going to look like is just like one resistor, 1 plus 1.55, 2.55 ohms. All right. So right now, that's my equivalent resistance right there. It's 2.55 ohms. So I've already answered part of what we're looking for here. 2.55. Keep in mind, we did do some it's a pretty big rounding there. I'm not doing sig fig stuff, which would be 1. But I think 2.55 gets us a better feel for the resistance as opposed to 3. All right, so now I can try to figure out what's the total current for this circuit right here. Well, my voltage source is not changing. It's 12 volts. My equivalent resistance is 2.55 ohms. So let me scroll down. And so let's go through Ohm's law. So let's figure out the total current would be equal to the voltage source over the equivalent resistance. So we're looking at 12 volts over 2.55 ohms. Actually should be able to do that one maybe. But let's go 12 divided by 1, nope, 2.55. 4.7. Oh, good, that rounds easy. All right, so the total current, thank you, Flipboard, 4.7 amps is the total current flowing through this monstrosity right here. So 4.7 amps is my total current. All right, so now how do I go through and I start looking through? For instance, looking at this current here, this current is in series, and I know that the current is the same for all resistors in series. So resistor 1 here is in series, so I know that this current is going to be the current for resistor 1. All right, that part's easy. Now to figure out what's the voltage drop for resistor 1, really I just go back, I look at Ohm's law. I equals V over R. In this case, if I'm looking for the voltage drop across that circuit, I'm looking for V. So for Ohm's law, sorry, I should have warned you, I'm scrolling down. So if I is V over R, if I want to solve for just V, just multiply both sides by R. Voltage is equal to current times resistance. So I'm not even going to do this one on paper even. So current, 4.7 amps times resistance, 1 ohm. The voltage drop across that resistor is 4.7 volts. Pretty easy, pretty basic. But now I'm going into the series circuit here. So to start off with, so I know that the V, and the I, so I'm looking at this circuit right here, right? And I know that the current, going through the whole thing is I should say even from this part here, I got 4.7 amps going through this circuit here. So if I wanted, this is where things are going to get a little bit tricky. So this is resistor, what did I say that was, like 2 through 4. All right, so now if I want to know the voltage drop across 2 through 4, I'm still just using this equation right here. So we're going to say that the change in voltage for 2, 3, 4 is going to be equal to the current 4.7 amps times the voltage here, which is 1.55 ohms. That I know I can't do in my head. All right, so I've got 4.7 times 1.55. 7.3 is what I'm going to round that to, all right? So the voltage drop here is 7.3 volts, okay? So now if I'm looking at, this is even a simplified circuit here. But the big thing to know is that I can kind of treat that as if it's hooked up to its own 7.3 voltage source. 2 ohms there. And here, 7 ohms. All right, so if I want to know the current, the thing we know about parallel circuits though is the voltage is the same for both resistors. So that 7.3 volts we figured out, that's the voltage for 2 for sure. Okay, and we're going to come back and work with this one a little bit, all right? So now I need to figure out 7.3 volts. I need to know the current going through this 2 ohm resistor one. Let's just start with that one. That was resistor 2. So I know that current is equal to voltage over resistance. So I2, the voltage for 2 is 7.3 volts over 2 ohms. Can't do that in my head. 7.3 divided by 2. 3.65. Let's go 3.7. All right, so the current going through resistor 2 is 3.7 amps. All right, so the current going through this part of my complicated circuit, 3.7 amps. For this part here, before I can figure out the current through each one, I need to figure out the current going through both of them, okay? Since they're in series, the current for these should be the same. So let's go back down here. Get that fixed at some point. That's cool. Control Z. Nope. Where'd there we go. Huge break there. You got a little bit of a mental break. A little weird. I'd have to like redo that whole thing. All right, so now I need to look at what's the current for 3 and 4. That's really professional. All right, so now we're still using 7.3 voltage, 7 ohm resistance. So 7.3 volts, 7 ohms for that equivalent resistance there. Learn not to click there again. 7.3 divided by 7. 1 point, let's call that 1. So that's going to have a current of 1 amp, okay? So the current going through 3 and 4 is 1 amp. And since 3 and 4 are both in series, they're both going to have the same current. So we're going to have 1 amp here, and we're going to have 1 amp here. So I'm almost done. Now that I know the current going through these two resistors here, I just need to figure out what's the voltage drop across each resistor. Luckily, my job's pretty easy here. I already figured out that to solve for voltage, I just take current times resistance. And since my current is 1, my math got super easy. So for resistor 3, current was 1 amp. If I want to know the voltage drop across that, 1 amp times 3 ohms should get me 3 volts. And then for the 4 ohm one, what we're going to see for a voltage drop is going to be very similar. We're going to have 1 amp times 4 ohms. That should be 4 volts. So we can kind of do some step-by-step comparisons here. So I know that the total voltage drop across here should be 7.3 from what I figured out here. And so 3 plus 4, that's pretty close to 7.3. Yeah, essentially it's just kind of going back to the basics of series and parallel resistors circuits. Um, Trying to figure out, am I keeping the current the same between resistors, or am I going to keep the voltage same between resistors? And so going back, once you have a handle of that, at that point you can just start combining resistors, find the equivalent resistance, and boil your circuit down into a one resistor simple circuit. The work does take a while, but it is really doable so long as you're kind of keeping track of what's what, maybe even drawing multiple diagrams to figure these things out. It's not too bad. Anyway, I hope that's somewhat helpful. Sorry about the break in there. Good luck.